Welcome to Prejim Technologies. I'm Venkat. This is part 44, Exception Handling Abuse Solved. In part 43, we have seen a classic example of exception handling abuse. In this session, we will see how to prevent that. Okay, so we'll jump straight back into the example. If you haven't watched part 43, I would strongly encourage you to do so before continuing with this example. All right, just a quick recap on what we have seen in the previous example. We asked the user to enter a numerator. We asked the user to enter a denominator. And when he enters a numerator, we are actually reading it from the console and trying to convert that to integer. And we know that if the user enters alphabets instead of numbers, it's going to throw a format exception. And in the catch block, basically we are saying please enter a number. And similarly, if he enters a very big number, again there will be an overflow exception when we try to convert that to an integer. Again, we catch that exception and then we say, okay, the number should only be between the minimum and maximum value that an integer type can hold. And similarly, if the denominator is 0, it tries to divide that and we get a divide by 0 exception, and we catch that exception and then we tell the user denominator cannot be 0. So basically you are allowing this program to throw the respective exceptions, and then you're using that exception handling basically to control what error messages to be shown to the user and subsequently the flow of the program, which is definitely exception handling abuse. Now we can actually rewrite this program, and without even having these exceptions occurring, we can present user with those respective messages. Okay, now let's see how to rewrite this program. So obviously, as usual, we'll ask the user to enter a numerator. Now instead of using the convert.toInt32 method, which will throw an exception if the conversion fails, within .NET framework we also have try parse method which we can use. So the way we do it is, actually let's say int numerator, and then if you look at the try parse method, so it's again on integer in 32.tryParse. If you look at the signature of this method, what is this method doing? It's going to return a boolean, a true or false. So if the conversion is successful, it will return true, otherwise it returns false. And if you look at the parameters that this method takes in, there is a string parameter. So obviously the number, I mean whatever the user input that the user has entered, so that string, and then you have to pass in an output parameter. Now if you're new to output parameters, I would strongly encourage you to watch a video tutorial on method parameters in this series. All right, so to read the input from the console, we use console.readLine, and we pass that as the first parameter. So obviously whatever the user has entered, read that and pass to this try parse method. Now this try parse method, what it does, it will convert that to an integer if possible, and returns that in this output parameter. So out, and then we pass the variable here, which will receive the converted value. So if the conversion is successful, if this method successfully converted that input to an integer, then it will store that in this variable. Okay, so now what we need to do, since this method returns a boolean, a true or false, okay, so we will declare a variable of type boolean, okay, is numerator conversion successful. Just a variable to determine if the conversion is successful. Okay, so if is numerator conversion is successful, in the sense if it has successfully converted that, then we know that there is no problem and we can continue to ask the user for denominator. So we'll do all this only if the numerator conversion is successful. So the next thing that we will do is basically ask the user to enter a denominator, and obviously just like for the numerator, now we'll copy paste this. So we'll create a variable which can receive the denominator value, and we can get rid of this line, and we will call this variable is denominator conversion successful. And then what we do, we read the user input that he has entered, and the converted value stored within this parameter variable denominator. Okay, so we have denominator as well right now. So what you need to do here is similarly, if is denominator conversion is successful, and at the same time it cannot be zero, it shouldn't be zero, because if the denominator is zero, the program will throw divide by zero exception. And is denominator not equal to zero, then what we do, we will go ahead and safely calculate the result and print the output to the user. Okay, uh, if is denominator conversion successful and denominator not equal to zero, right? Okay, on the other hand, if is numerator conversion is not successful, then what we want to do, we want to give a meaningful error message to the user, console.writeLine. So obviously we know that numerator conversion is not successful. Why? Because either he entered alphabets, or the entered value is beyond what an integer variable can hold. So what you can do is you can actually put a very meaningful message saying that numerator should be a valid number between whatever is the minimum and maximum value that an integer type can hold. So obviously what we can do here is in 32 dot min value and int 32 dot max value. All right. Similarly, if is denominator is successful and denominator not equal to 0, okay, calculate the result and display the result. Else, if denominator, it will come into the else block if either of these conditions is false. So if denominator is equal to 0, we know that a denominator cannot be 0. Else, we know that denominator conversion has failed. So if the denominator conversion has failed, then we want to say to the user, okay, denominator should be a valid number So denominator should be a valid number between the minimum and maximum value. On the other hand, if denominator is equal to 0, we can say denominator cannot be 0. So copy that and put it in the if block. Okay, now if you look at this, we are not allowing exceptions to occur. Instead, we are programmatically checking, okay, are the values what we expect? We are validating the user input. Similarly, we are seeing if the conversion is successful or not, and based on that, we are controlling what we want to display to the user, and we are in turn controlling the program logical flow. So after this modification, what you can basically do is actually get rid of all these exceptions, because there's no possibility for these to occur. And we can just leave the general exception block here, just in case if there is any other exception that we didn't anticipate, and if there is a chance of that happening, we can basically handle that there. But now if you run this, the behavior is going to be almost identical to what we have seen in part 43. But now this is a better way of programming. So now if I enter alphabets instead of numbers, so numerator should be a valid number. Similarly, if I enter a very big number which an integer cannot hold, obviously the conversion will fail and we get the same error. And similarly, if I enter a valid numerator, and if I enter 0 for the denominator cannot be 0. So it's doing all the validations it should be doing in the right way, but the difference between how we have written program now and in part 43 is that in part 43 we were using exception handling basically to control the logical flow, but in this part we are using programming techniques, and we are avoiding the exceptions from unnecessarily happening. So using exception handling to implement program logical flow is bad, and that is what is termed as exception handling abuse. And we have seen how to prevent that with good programming practices. For example, using try parse method instead of convert method. Convert method will allow the exception to happen, whereas try parse will return a true or false depending on the success or failure of the conversion. I hope you have enjoyed this session. On this slide, you can see C# and ASP.NET interview questions. That's it for today. Thank you for listening. Have a great day.